Hello and welcome to my walkthrough of the Pearson Edexcel GCSE November 2024 Mathematics Paper 2 Calculator Paper Higher Tier. Let's jump straight into it. Question 1. Use your calculator to work out the value of the square root of 208.3 minus 15.7 over 5.694 plus 1.8 squared. So what I'm going to type onto my calculator here is the square root button first. Then I'm going to open brackets and do 208.3 minus 15.7, just like that, 208.3 minus 15.7, then divided by, and we'll open brackets again, and we're going to do 5.694 plus 1.8 squared, and these brackets will just ensure that everything has been done in the correct order. 1.8 squared, close brackets, and equals, and we get 4.643069317. And the question wants us to show all the digits on the calculated display. Question number 2. The scatter graph shows information about some ships. It shows the length and the width of each ship. Part A. What type of correlation does the scatter graph show? It shows a positive correlation, because as length increases, width increases. Part B, draw a line of best fit on the scatter graph. You would do this using a ruler, but it will be something like this, that sort of runs through as many points as possible. A different ship has a length of 194 meters. Use your line of best fit to find an estimate for the width of the ship. So this here is 190, as it's the midpoint of 180 and 200. Each square represents 2, so 194 is here. Follow 194 up, and I get here. And follow that and across is just above the halfway point between 25 and 30. So I'm just going to say this is about 28 meters. The mark scheme gives you anywhere between 26.5 and 29.5. Question number 4. Tom was asked to draw a Venn diagram for the information given above here. Here is his answer. Write down 2 things Tom should do to make his answer fully correct. Well, the complete set is all the odd numbers between 0 and 20, and immediately I can see that the number 1 is missing from his diagram. So what he needs to do is he needs to include 1, and it should be in the outside region of the Venn diagram, as in this rectangle here, because it's not in A and it's not in B, but it is in the set. The other thing he's done is he's got 17 in here twice. So 17 shouldn't be in A circle, just in the intersection. And that's us done. Question number 3. In London, a 200-gram chocky bar costs £3.50. In Zurich, a 360-gram chocky bar costs 7.2 Swiss francs. The exchange rate is £1 equals 1.25 Swiss francs. In which city is the chocky bar the better value for money? In London or in Zurich? You must show how you get your answer. So as we have a 200 grams and a 360 grams, we're going to look at per 100 grams what the best value for money is. So for the London bar, all we have to do is divide the 200 grams by 2 to get to 100 grams. So we'll divide the £3.50 by 2, and we get £1.75 per 100 grams. The Zurich one is a little bit more complicated. So for 360 grams, 7.2 Swiss francs is going to be 7.2 divided by 1.25 in pounds. To convert it, so on my calculator, 7.2 divided by 1.25 is £5.76. Then to get from 360 to 100 grams, we have to divide by 3.6. So what I'm going to do is 5.76 divided by 3.6 to get the value for money per 100 grams. So that's going to be £1.60 per 100 grams, which is cheaper. Therefore, Zurich is better value for money. Question number 5. Complete the table of values for y equals x squared minus 2x minus 3. So when x equals minus 2, we're going to get x squared is 4, minus 2 times minus 2 is minus 4 is plus 4, so add the 4 on there and take the 3 off. So we get 5 to go in the first box. When x is 0, we're going to get 0 squared, which is 0, minus 2 times 0, which is 0, minus 3. So we're just going to get minus 3 here. When x is 1, we're going to get 1 squared, which is 1, minus 2 lots of 1, which is 2, and minus 3, which is just going to be minus 4. When x is 3, we're going to get 3 squared is 9, minus 2 times 3, which is 6, minus 3, which gives 0. And lastly, when x is 4, we're going to get 4 squared, which is 16, minus 2 times 4, which is 8, minus 3, and that gives us 5. Part B, on the grid, draw the graph of y equals x squared minus 2x minus 3. So we're going to plot minus 2, 5, which is over here, minus 1, 0, which is here, 0 minus 3, which is here, 1 minus 4, which is here, 2 minus 3, which is here, 3, 0, and 4, 5. It is a quadratic equation, so we're expecting that shape of the graph, and we're just going to connect the points in the best way we can. Just doing it freehand, so that's very wobbly. Should be a bit more smooth than that, but that's what you should be expecting for your answer. Question number 6. The cost of a first-class stamp increased from 76p to 85p. The cost of a second-class stamp increased from 65p to 66p. Philip says the percentage increase in the cost of a first-class stamp is more than 7 times the percentage increase in the cost of a second-class stamp. Is Philip correct? You must show all your working. So for a first-class stamp, it's gone from 76p to 85p. So that is a 9p increase. 9 divided by 76 times 100 is going to give us the percentage increase. I'll just do that on my calculator. 9 divided by 76 times 100 gives me 11.84%, roughly. For a second class stamp, we've got a 1p increase. So we're going to do 1 divided by the 65 that we had originally, times by 100. 1 divided by 65 times by 100 gives us 1.54%, roughly. And Philip is saying that the first class percentage increase is more than 7 times the second class percentage increase. So what I'm going to do is 7 times 1.54. Still had the number on my calculator, so I could just type in times 7. And that is about 10.77%, roughly. Therefore, Philip is correct, because the increase in the first class stamp is greater than 7 times the increase in the second class stamp percentage. Question 7. The diagram shows triangle ABC. In the diagram, all measurements are in centimetres. AC equals BC. The perimeter of the triangle is 72 centimetres. Work out the area of the triangle. Well, we can say straight away 2x plus 11 equals 4x minus 4, as we're told that AC equals BC. So we can say, we'll take the 2 onto the other side. We have 2x equals 15 when we add 4 to both sides, so x equals 7.5. Then we can say, therefore, that AB is 2 times 7.5, which is 15, add 5, which is 20. And both sides are then going to be the same length, AC and BC. So x is 7.5 up here. That's going to be 15. That's going to be 11. That makes these side lengths 26. What we're going to do is half base times height. So we need to find out the height of this triangle. That's right down the middle. So this is going to be 10 here. Using Pythagoras, we can say that 10 squared plus, let's call this y, plus y squared equals 26 squared. So we'll just do that on my calculator. 26 squared is 676 minus 100. So y squared equals 576. The square root of 576 is 24. So half times base, which is 20, times height, which is 24. Do that on my calculator. We get 240 centimeters squared is our answer. Question number 8. 1.25 times 10 to the minus 12 equals k times 4 times 10 to the minus 20. Work out the value of k. Give your answer in standard form. So by rearranging this, we're going to say k equals 1.25 times 10 to the minus 12 over 4 times 10 to the minus 20. I'm going to do that on my calculator by putting the top in brackets. So open bracket, 1.25 times 10 to the power minus 12, close brackets, divided by, open brackets again, 4 times 10 to the power minus 20, close brackets, and I get 3125 and then 4 zeros, or 3.125 times 10 to the 7. If we had a decimal point here, how many positions have we moved it from here where it started? 1, 2, 3, 4, 5, 6, 7. Question number 9. The diagram shows two congruent regular 9-sided polygons. ABCD is a quadrilateral. Show that ABCD is not a square. So what I'm going to say is if ABCD is a square, then all angles in the shape are 90 degrees. So all I have to do is prove that one of the angles isn't 90 degrees. So what I'm going to do is let this equal x. Now we know that all the angles in a circle, or about a point in this scenario, add up to 360. So if I call this A and this B, we know that A plus B plus X equals 360. Since these are regular 9-sided polygons, we know that A is going to equal B, and also that every angle inside the polygon is going to be the same. Now, angles in a 9-sided polygon add up to, so I'll do this up here so it's a little bit clearer. If it's a 3-sided shape like a triangle, the angles add up to 180. 4-sided shape like a square, they add up to 360. 5-sided shape, 540, and so on, 7, 8, 9. So 6-sided is 720, 7-sided is 900, 8-sided is 1080, and a 9-sided shape is 1260 degrees. As it's a regular polygon, every angle in there is going to be the same. So we can say A equals 1260 divided by 9. And on my calculator, 1260 divided by 9 is 140 degrees. And this equals B as well, as that's also a regular polygon. Therefore, 140 plus 140 plus x equals 360. Therefore, x equals 80, not 90, so not a square. Question number 10. Use algebra to solve the simultaneous equations 4x minus 5y equals 20, 6x plus 7y equals minus 57. So what I'm going to do here is I'm going to call this equation 1 and this equation 2. I know that 4 multiplied by 1.5 gets me 6x. So then once I have 6x in two separate equations, I can combine those equations to get y on its own, and I can work out what y is. Then using that, I can work out what x is. So what I'm going to say is equation 1 multiplied by 1.5. So 4 times 1.5 is 6x. 5y times 1.5 is going to be 7.5y. And 20 multiplied by 1.5 is 30. So now what I can do is call this equation 3 and say equation 2 minus equation 3. We're going to get 6x minus 6x gives us 0x. 7y minus 7.5y gives 14.5y. And minus 57 minus 30 gives us minus 87. Then I can say that y, therefore, is minus 87 divided by 14.5. And on my calculator, that is just minus 6. And now we have minus 6. We'll put that into 1. We have 4x minus 5 lots of minus 6 equals 20. So 4x plus 30 equals 20. So 4x equals minus 10. So x equals minus 2.5. And we're done. Question number 11. Describe fully the single transformation that maps triangle A onto triangle B. So we can see straight away that the triangle's getting smaller. So it's going to be enlargement, but the enlargement is going to be less than 1 because it's getting smaller. So we can see we have 3 squares long at the top and 2 long for B. Or we have 1, 2, 3, 4, 5, 6 long, 6 height there, or 4 height for B. So we've gone from 3 to 2 in width, 6 to 4 in height, which means it's an enlargement of scale factor 2/3, as 4 is 2/3 of 6 and 2 is 2/3 of 3. And to find the center of enlargement, we just need to draw straight lines between similar points. So I'm doing this on my iPad, so I don't have a ruler here, but you basically need to draw a line, making sure you go through both of the similar points. And what you should find is, if I've drawn this straight, which you can see I absolutely have not, but use a ruler in the exam, what you should find is that there is one point that all 3 go through, and that will be your center of enlargement. Now, as you can see, it's a little bit off because I haven't used my ruler, but we can say it has a center of enlargement of -4, -2. Question number 12. The diagram shows a solid cylinder with base radius 3 centimeters and height 8 centimeters. It also shows a solid cube with side length h centimeters. The cylinder is made from steel with a density of 7.86 grams per cubic centimeter. The cube is made from brass with a density of 8.5 grams per cubic centimeter. The mass of the cylinder is equal to the mass of the cube. Work out the value of h. Give your answer to 1 decimal place. So, if the mass of the cylinder equals the mass of the cube, we're going to need to work out the mass of both of the two shapes, and then we can use that to work out the side length h by getting the volume of the cube. So, firstly, we're going to find the volume of the cylinder. So we know the volume of the cylinder is pi times r squared times height, where r is the radius. So that's going to be pi times 3 squared, which is 9, times by height, which is 8. So 72 pi, which I'm just going to do on my calculator. 72 pi is the equivalent of 226.19. Now we have that, we can use that to find the mass of the cylinder. Now, if you can't remember the formula for the mass of the cylinder, the units sort of give it away up here. So we know that the density, which is usually given by P, is grams per cubic centimetre. So grams is your mass, cubic centimetre is your volume, so your density equals mass over volume. So we can rearrange this to say the mass equals density times by volume. We know that the density is 7.86. We've just worked out the volume is 226.19. So I'll do this on my calculator and I get 1777.89, and that is the mass of the cylinder, so it's in grams. We know that's the same as the mass of the cube. So what we'll do now is we have the density of the cube. We're going to use these to work out the volume of the cube using the same formula we used earlier. So we have density equals mass times volume. So volume equals mass over density. The mass is 1777 equal 0.89 over the density, which is 8.5. And that makes the volume, again I'll do this on my calculator, 209.16 centimetres cubed. All we've got left now is to do the cube root of this number, as the volume of a cube is just each side multiplied by each other and multiplied by itself again. And they're all the same length, so we can just do the cube root. So I'll just put this in my calculator and I get 5.9 centimetres. They want the answer correct to one decimal place. So we are done. Question number 13. Here is a table of values of x and y. Nadia says that y is directly proportional to x because the value of y increases by 4 as the value of x increases by 2. Part A. Is Nadia correct? You must give a reason for your answer. So we can say no, Nadia is not correct. For directly proportional, it needs to have a format of y equals kx, where k is a constant. So it doesn't matter what the value of y and x are, this should always work if they're directly proportional. So when x equals 4, for example, y equals 4, therefore k would be 1. But when x equals 6, y equals 8, therefore k would be, it doesn't really matter what it would be, k would not equal 1. So it isn't a constant, so not directly proportional. Second part then, w is directly proportional to the square root of t. So before I go any further then, I'm just going to write a formula of w equals k times the square root of t, where k is a constant. W equals 140 when t equals 64. Part BI, calculate the value of w when t equals 7.84. So since we're given w equals 140 when t equals 64, we can say 140 equals k times the square root of 64. Therefore, by rearranging this, this is just 140 divided by the square root of 64. Square root of 64 is 8. So 140 divided by 8 on my calculator is just 17.5. They want us to find the value of w when t equals 7.84. So w equals 17.5 times the square root of 7.84. Again, I'll do this on my calculator. Square root of 7.84 is 2.8. Times that by 17.5, and we just get 49. And the second part of part B, on the axis below, sketch a graph to show the relationship between w and t. This will be a straight line, and it will go through 0, 0, as it's directly proportional. Do that with a ruler in your exam. And we're done. Question number 14. There are 10 football teams in a league. Each team plays every other team 4 times. Work out the total number of games played. So we have 10 teams. Let's call team A. So team A is going to play every other team, so 9 other teams 4 times. So team A, 9 times 4 number of games. Team B is also going to play all the other teams, which are 9 other teams 4 times. However, we have already included every game that Team A are going to play in the first line. So the games that Team A are going to play against Team B are already included. So what I'm going to do here is do minus 1 times 4 for all the games that they play against Team A. Team C, 9 times 4, minus 2 times 4, because all the games they're going to play against Team B are already included, and the games they're going to play against Team A are already included. So this will be 9 times 4, this will be 8 times 4, this will be 7 times 4, and so on. So D will have 6 times 4, 5 times 4 for E, 4 times 4 for F, 3 times 4 for G, 2 times 4 for H, and 1 times 4 for Team I. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. The last one will have 0 times 4, because everybody else will have already included their games against that team. So that's your 10 teams. All we have to do here, 36, 32, 28, 24, 20, 16, 12, 8, 4, and 0. Add all these up, and you get 36 plus 32 plus 28. I'm just going to put this in my calculator. Plus 16 plus 12 plus 8 plus 4. And I get a total of 180 games. Question 15. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. So the distance between each term here is what we'll look at first. So 3 and 20 we have a gap of 17. 20 and 47 we have 27. 47 and 84 we have 37, and 84 and 131 we have 47. So what we're then going to look at is the gap between these new numbers. So 17, 27, 37 and 47. That's because this is a quadratic sequence. Gap between these is 10, gap between these is 10, and the gap between these is 10, which is great. So we can say that the number that's going to sit in front of the n squared element of our quadratic sequence, which we'll call a, so I'll just write this up here, a n squared plus bn plus c, is going to be our quadratic sequence. 2 lots of a is going to equal 10. So a must be 5. So if we then say for each term, 1, 2, 3, 4, 5, for the n squared part of the term, this is going to be 5n squared, so that's going to be 5 times 1 squared. This is going to be 2 squared is 4 times 5 is 20. This is going to be 45. This is going to be 80. And this is going to be 125. What we need to do next is subtract these numbers off of our original terms at the top up here. So I'm just going to write these again. So 3, 20, 47, 84, and 131. So subtracting these off, we get minus 2, 0, 2, 4, 6. And as you can see, this is increasing by 2 each time, which means our bn plus c element, we know the b part is going to be 2. So we can say, we'll go up here, for term 1, we have 5n squared, we'll just write up here, 5n squared plus 2n plus c. For 1, we have 5 lots of n squared, which is 5, plus 2 lots of 1, which is 2, giving us 7. For the second term, we have 2 squared is 4, 5 lots of that is 20, plus 2 times 2, so 24. 3 squared, 45, 3 squared is 9 times 5 is 45, plus the 6 is 51, we'll stop there. And what we actually have is 3, 20, and 47. Should be able to see that 7 take 3 is 4, 24 take 20 is 4, and 51 take 47 is 4. So we need to do 5n squared plus 2n minus 4. And that should be our answer. The terms of a different sequence are given by the rule un plus 1 plus kun plus k, where k is a constant. Given that u1 equals 9 and u2 equals 4, find the value of u4. So what do we have? u1 equals 9, which means u2 is going to equal k lots of u1 plus k, which is k lots of 9 plus k, so 10k. We are told that u2 equals 4. That means, nice and easy, k equals 4 over 10, or 2/5. u3 is then going to be 2/5 times u2, which is 4, plus 2/5. So that's going to be 8 over 5 plus 2 over 5, which is 10 over 5, which is the same as 2. And u4 is going to be 2/5 lots of u3, which is 2, plus 2/5, which is just going to be 6 over 5, or 1.2. And we're done. Question 16. The histogram gives information about the distances that 60 teachers travelled to school on Monday. The histogram is incomplete. 11 of the teachers travelled between 0 miles and 5 miles. None of the teachers travelled a distance greater than 50 miles. The number of teachers who travel between 5 miles and 10 miles is the same as the number of teachers that travel between 20 and 30. Complete the histogram. So all we're given here is that 11 of the teachers travelled between 0 and 5 miles. So that's this first bar here. So this is 11 people. Now you can see this goes up to 2.2. So the frequency density is 2.2. The distance equals 5, and the frequency equals 11. So we can easily see that the frequency divided by the distance is the frequency density. So for this second box here, we know the distance is 10. We can see that the frequency density is 1.5, which means the frequency must be 10 times 1.5, just by the same definition of what we did on the left-hand side here. If we look at this box here, we know the distance is 20. We can see that the frequency density goes up 3 boxes, so that's just going to be 0.3. Times these together again, you get the frequency equals 6. So we have 11 people, 15 people, and 6 people, giving us 32 people. There's 60 in total, therefore 28 people are left. We are told the number of teachers that travelled on the other two distances is the same, therefore it's 14 each. So between 5 and 10, we have the distance is 5. We know the frequency is 14. Therefore, the frequency density is just going to be 14 divided by 5. And that gives us 2.8. So I need to do that on this graph. That's going to be here. Just to fill in this of the histogram, use a ruler during your exam. And then the other one is going to be a distance of 10. The frequency is still 14, and so the frequency density is 1.4 for this one. And that's just going to be up to here. That's a wiggly line. And there you go. And that will be us done. Question 17. Show that 6x minus y over 10xy plus 1 over 2x minus 2y minus 7x over 5xy simplifies to k over y, where k is an integer. First thing you need to do here, make a common denominator. And what I'm going to do is make them all over 10xy. So we have 6x minus y over 10xy. To get 1 over 2x over 10xy, I need to times the top and the bottom by 5y. So 5y multiplied by 1 over 5y multiplied by 2x. And then when that expands out, that will be 10xy. And then this one, 5xy already on the bottom, so we just have to times the top and the bottom by 2. 2 lots of 5xy. So we can now write this as 6x minus y plus 5y minus 4y plus 14x all over 10xy. So if we now simplify this out, you can see minus y minus 4y cancels with the plus 5y. And then we'll put together the x's so that we have 20x over 10xy. Now you can see x cancels here, and the 20 divided by the 10 just gives us 2. So our answer is 2 over y, which is in the format that they want. Question 18. A, B, and C are 3 points on a circle centre O. BA equals BC. Prove that OB bisects angle ABC. So it wants us to show that it goes right through the middle of angle ABC. So we know that BA equals BC. We also know that if I draw a line from O to A, which would be a straight line, that is the radius of the circle. That's also true if I draw it from O to C. And that's also true if I draw it from O to B, because that's the centre of the circle. So I'm going to write OA equals OB equals OC equals the radius of the circle. I'm going to say this angle here is x. So we'll say let's AOC equal x. And then we can say that ABC, this angle here, ABC equals x over 2. And this uses one of our circle theorems, as the angle at the centre is twice the angle at the circumference of a circle. Okay, so we know that AB equals BC. We knew that already. But we also know that OA equals OB, which equals OC. So both of these two triangles, this one here and this one here, must be congruent, because BC, I'll actually just write it here, BC equals AB and OC equals OA, and OB is in both triangles. So we have 3 sides of the triangle that are exactly the same length. Therefore, triangles AOB and BOC are congruent. So that tells us that these angles here, which I will call y, must equal each other. And we'll say, therefore, y plus x has to equal 360 degrees, as it's all round the centre of the circle. I'll actually write that as well. Angles about a point equals 360 degrees, just so you make sure you're saying absolutely everything to the examiner. Therefore, we can say 2y equals 360 minus x. Therefore, y equals 360 minus x over 2, or 180 minus x over 2. We also know, in fact, I might actually just give these smaller angles a name. Let's call these A and B. So we also know that since OB equals OA, this is also an isosceles triangle. So this angle here must be A, and this angle here must be B. So isosceles. Therefore, y plus 2a equals 180, due to angles in a triangle adding to 180. Now we'll just replace y with what we had earlier, so 180 minus x over 2 plus 2a equals 180. We can rearrange this to say 2a equals x over 2, therefore a equals x over 4, and therefore, since we do exactly the same thing with b, b also equals x over 4, which means OB bisects ABC as it goes right down the middle. And we have proved that since the fact that B is exactly half and A is exactly half of the full angle ABC. Question number 19. T equals W over A minus C. W equals 435, correct to the nearest 5. A equals 9.8, correct to 2 significant figures. C equals 2.5, correct to 2 significant figures. By considering bounds, calculate the value of t to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. So first, for w, we know it's 435 correct to the nearest 5, so the smallest it could possibly be is 432.5, because anything less than that, it rounds it down to 430. The highest it can be is 437.5. For the same reason, it would go up to 440 otherwise. For A, similar fashion, the smallest it can be is 9.75. The biggest it could be is 9.85. And for C, the smallest it can be is 2.45. Biggest it can be is 2.55. Okay, so let's just rewrite that nicely. 432.5 is less than or equal to W, which is less than 437.5. 9.75 is less than or equal to A, which is less than 9.85. And 2.45 is less than or equal to C, which is less than 2.55. Okay, so we need to work out the biggest and the smallest that T can be. So T minimum is going to be when W is as small as possible. So that's going to be 432.5. And when A minus C is as big as possible. So A needs to be as big as possible, so 9.85. But C needs to be as small as possible to not take away the fact that you want the denominator to be large. So this is going to be 432.5. Let's do my calculator. 9.85 divided by 2.45, and then 432.5 divided by that. I get 58.45, roughly. T maximum needs to be when W is as big as possible, 437.5. And when A minus C is as small as possible, which means A needs to be as small as possible, so 9.75, and we need to subtract away the bigger number this time, 2.55. Again, I'll do this on my calculator. 9.75 minus 2.55, 437.5 divided by that, I get 60.76. The question wants us to calculate a value of t to a suitable degree of accuracy, we know that t is between 58.45 and 60.76. We're therefore going to say t equals 60. Question number 20. VABC is a solid pyramid. ABC is an equilateral triangle. M is the midpoint of AB. F is the point on MC such that MF compared to FC equals 1 compared to 2. The vertex V is vertically above F. VA equals VB equals VC, VF equals 8 centimeters, angle VCM equals 52 degrees. Work out the side length of the equilateral triangle ABC. Give your answer correct to one decimal place. Okay. So first things first, we know VF is 8 centimeters. So let's draw a line down to F, and we'll consider this as a right-angled triangle. So let's just draw a triangle here. This is V, this is F, and we will run it through to C. So we have this triangle effectively, C, and this is our right angle. We know it's 8 centimeters high. We also know that the angle VCM is 52 degrees. And since F is on the line CM, the angle's the same there. So we can work out the side length FC using tan. So we have the opposite, we need the adjacent, and we have the angle there. So 8 divided by FC is opposite over adjacent, tan 52. Therefore, FC equals 8 divided by tan 52. I'll just do that on my calculator. 8 divided by tan 52 is 6.25 roughly centimeters. Next, we can say that we know that MF compared to FC is a ratio of 1 to 2. So 1/3 of CM is MF and 2/3 of CM is FC. Therefore, we can say that MF is going to be half of 6.25. So that's 3.125. And the full MC length is going to be 3.125 plus the 6.25 we had earlier, 9.375. Almost there. Now we will look at trying to actually work out what the question wants us to do, which is to find one of the side lengths. So if we look at this one that I'm drawing now on the diagram, this triangle here, which I will draw down here, which is going to be ACM. It's another right-angled triangle. We know that this angle here is 30, as it is half of the 60 of the equilateral triangle, as it's on the midpoint. MC is the midpoint line that bisects the angle. And A angle here is going to be 60 because it's on the equilateral triangle ABC. We know that this length here is 9.375 as we worked that out earlier. What we need to do now is take tan again. So we will use this angle here, I think, and call this X. So 9.375 is the opposite. So tan of 60 equals 9.375 over X. Therefore, X equals 9.375 over tan 60. 9.375 over tan 60 on my calculator gives me 5.41. And what we've just worked out is AM, this one here. Twice that gives us AB, which is one of the side lengths of the equilateral triangle. So our answer is 10.8 centimeters. Question 21. The point P has coordinates -4, 5. The point Q has coordinates 6, -6. The point R has coordinates K, K plus 3. Given that angle PRQ is a right angle, because of this, I'm just going to write as we go, PR and RQ perpendicular. It's important. Find the possible values of Q. You must show all your working. So if I start looking then at the gradient of PR, This is going to be your difference in your y over your difference in your x. And p and r are both on the same line. So the difference in y is going to be 5 minus k. The difference in 5 minus k plus 3, sorry. Difference in x is going to be minus 4 minus k. So this can simplify to 5 minus k and then 5 minus 3. So 2 minus k over minus 4 minus k. We'll just flip this around. All the minuses go the other way. So k minus 2 over k plus 4. Gradient of RQ, again we'll do dy dx, is going to be a difference in y, which is k plus 3 minus 6, so plus 6, over k minus 6, which we can simplify to k plus 9 over k minus 6. We already know p and r are perpendicular, so p r RQ perpendicular. Therefore, gradient of PR equals minus 1 over the gradient of RQ. So, k minus 2 over k plus 4 equals minus 1 over k plus 9 over k minus 6, which we will rewrite as minus k minus 6 over k plus 9, or 6 minus k over k plus 9. So now we have k minus 2 over k plus 4 equals 6 minus k over k plus 9. We'll multiply out the two denominators to get k minus 2 multiplied by k plus 9 equals 6 minus k multiplied by k plus 4. We'll expand this out. We get k squared minus 2k plus 9k minus 18 equals 6k minus k squared, 6k minus k squared plus 24 minus 4k. Simplify this out, we're going to get 2k squared on this side, minus 2 plus 9, so we have a plus 7k. On the other side we have a plus 2k, so we're going to end up with a plus 5k, minus 18 minus 24 gives you minus 42 equals 0. Do the quadratic formula. Minus b plus minus the square root of b squared minus 4 times a times c all over 2a. It's going to be minus 5 plus minus the square root of 4 times 2 times 42. The minus signs cancel out. We've got 336 plus 25, 361 over 4. And hopefully 361 has a square root. It does, 19. So minus 5 plus minus 19 over 4. Therefore, we have minus 5 plus 19 gives you 14 over 4 is the same as 7 over 2. Or minus 5 minus 19 minus 24 over 4 gives you minus 6. And that is your final answer. Question 22. There are only red counters and yellow counters in a box. 3/5 of the counters are red. Sophie takes at random 2 counters from the box. The probability that the 2 counters are the same colour is 41 over 80. Work out the total number of yellow counters in the box. You must show all your workings. So, for them to be the same colour, it must be red, red plus yellow, yellow. The probability of red, red is not quite as simple as 3/5 times 3/5. It's going to be basically R out of R plus yellow, which is going to be your total number in the bag, multiplied by R minus 1, because 1's now come out the bag, over R plus yellow minus 1. And similarly, probability of YY is going to be yellow out of R plus yellow, multiplied by yellow minus 1. over r plus yellow minus 1. So we already know that 3/5 of the counters at the start are red. So we can say the probability that you're going to pick a red counter at the start is 3/5. So we can say this is the same as 3/5 times r minus 1, r plus y minus 1. Similarly, to pick a yellow counter, it's going to be 2/5 times y minus 1 over r plus y minus 1. So let's expand this out, make this a little bit easier. So we can say this is 3 lots of r minus 1 over 5 lots of r plus y minus 1. And then this one is going to be 2/5 y plus 1. So 2 lots of y plus 1 over 5 lots of r plus y plus 1. If we add these together, we know this is going to be 41 over 80, as we're told that the probability of the two counters being the same as that. So this is also the same denominator, which makes it a little bit easier. So 3r minus 3 plus 2y minus 2 over 5 lots of r plus y minus 1 equals 41 over 80. Let's multiply this up and get these all the same. So 80 lots of 3r minus 3 plus 2y minus 2 equals 41 times 5 lots of r plus y minus 1. Expanding this out, we get 240r minus 240, 160y minus 160. 41 times 5 is 205, so 205r, 205y minus 205. Simplify all this. So we get 35r, we get what we've got minus 400, and then we've got minus 205, so minus 195 equals 45. Y. Let's divide through by 5. Let's make this a lot easier. 7r minus 39 equals 9y. So we're almost there. So one thing we haven't mentioned is that since 3/5 are red and 2/5 are yellow, we can say that r equals 1.5 times y. So let's pop that into our equation at the bottom. So 7 times 1.5y minus 39 equals 9y. That means 10.5y minus 9y equals 39. 1.5y equals 39. So 39 divided by 1.5 is 26. And our answer, which what we want, the number of yellow counters, y is 26. Thank you very much for watching as ever. Drop a like and a follow if you enjoyed and found it helpful, and I'll catch you next time.